Hello, my name is Ashish Thorat. I am currently studying in third year mechanical engineering at D.Y. Patil College of Engineering, Akurdi, Pune. Today I am here to present on the topic helical gear. Let's begin with introduction to helical gear. Definition: helical gear are type of cylindrical gear with teeth cut at angle to the gear axis. Unlike spur gear, their teeth engage gradually, providing smoother and quieter operations. Some key features are teeth are inclined at helix angle and load is distributed over several teeth. Can transmit motion between parallel and non-parallel shafts. Means it can transmit motion through parallel shafts and also non-parallel shafts. Then terminology of helical gear. First of all, helix angle, which is represented by beta, the angle between the gear tooth and axis of rotation, means the axis of rotation and helix makes an angle which is called as helix angle. Then pitch circle. Pitch circle is imaginary circle that rolls without slipping when messing with another gear, means this line is representing pitch circle. Then axial pitch is distance between similar points on adjacent teeth measured along with gear axis. Then normal pitch is measured in the plane normal to the tooth. Then face width is the width of the gear tooth, means from this to this distance is face width, which is represented here. Then addendum. What is addendum? Addendum is radial distance from pitch circle to the top of the tooth. Means from pitch circle to the top of the tooth is called addendum. Then what is dedendum? Dedendum is radial distance from pitch circle to the bottom of the tooth. Means from pitch circle to the bottom of the tooth is called dedendum. Then lead. What is lead? The distance the helix travel along the axis in one complete turn around the gear is called as lead. Then forces on helical gear. There are three forces on helical gear. First of all is tangential force, then radial force, then axial force. First of all, tangential force. Tangential force is the main force that transmit the torque. It acts along the tangent to the pitch circle, which is represented here, and it can main force that transmit torque and acts along the tangent of pitch circle, which is shown here. Then radial force is act toward away from the center of the gear, means it can through the gear and or away from the gear, which is here PR. Then axial force acts along gear axis, which is here PA, which acts along gear axis caused due to helix angle and tries to push gear along its shaft. The combination of these three forces determine the resultant force. Now, some important design consideration for helical gear are material selection. Material selection is important, so strong and wear resistance material like alloy steel are preferred, and surface treatment can improve gear lives, like carburizing. Then helix angle. Larger helix angle can improve smoothness but increase axial load. Means larger helix angle can improve its axial load, and the typical helix angle between lies between 15 degree to 30 degree for balance. Then face width. Wider face width can carry more load but need stronger support. Means wider the face width, it can support the stronger. Then tool strength. To strength, teeth must be strong enough to handle bending and surface stresses. Then bearing selection. Bearing selection must support both radial and axial forces. We cannot apply any bearing to any shaft or gear, because it is very important that particular bearing needs particular shaft. And then lubrication is also important for smooth transmission, and proper lubrication reduce friction, wear and heat generation. Then alignment. Accurate shaft and gear alignment is critical for smooth operation and long life. Then heat dissipation. In high speed application, heat management become important. If we cannot consider heat dissipation or heat management, we can fail our gear. Now let's talk about beam strength of helical gear. To, to determine the beam strength, we consider helical gear equivalent to formative spur gear in a plane perpendicular to the tooth element. The pitch circle diameter of the gear is d dash and the number of teeth is z dash and the module is mn. The beam strength of spur gear is given by SB is equal to mb sigma b y, which is take as a. Then this equation is also applicable to formative spur gear, which means we are getting this equation from formative spur gear. Then what is SB? SB is beam strength perpendicular to tooth alignment. Then M is normal module. And then what is phase width? Phase width become B by cos psi. And then B here and B, B becomes B by cos psi. And psi means helix angle. Then what is y? Y is Levy's form factor based on virtual number of teeth z dash. Then substituting the value of in equation A, we get the value of SBN is equal to mn b sigma b y divided by cos psi, and which we represented by b. Then in figure, SB is the component of SBN in the plane of rotation. Thus, SB becomes SBN cos psi, and from B and C we get SB is equal to MB sigma B Y. This equation is called Levy's equation for helical gear. In this equation, form factor Y is based on virtual number of teeth. The equation gives beam strength in the plane of rotation. Therefore, beam strength SB indicates maximum value of tangential force that tooth can transmit without bending failure. Now, for wear strength of helical gear, the wear strength equation of spur gear is modified for helical gear by considering a formative pinion and gear in the plane of perpendicular to the elements. The wear strength denoted by SW is given by the equation BQ D dash PK, and referring to the figure, SW becomes SWN, means wear strength perpendicular to the tooth element, and phase width become B by cos psi, and then pitch circle diameter of formative pinion becomes dp dash, means dp by cos square psi. Then substituting the value in equation A, we get the SWN value BQ dpk upon cos square psi. The component of SWN in the plane of rotation denoted by SW, and by the SW we get SWN into cos psi, and after the transferring cos psi here is upon the SW, we get SWN is equal to SW upon cos psi, and after substituting in from B and C, we get SW is equal to BQDPK upon cos square psi, which is our final equation. This is our final equation, which is known as Buckingham equation for wear strength. Now finally, let's see where helical gears are commonly used in automotive industry, where they are used in vehicle transmission for smooth and quieter power delivery. Then in industrial machinery, they are used in conveyor, compressor, pump, where high load handling and smooth operations are critical. In elevators and lift, helical gear are help ensure efficient and quieter motion. Then another aerospace application, they are found in aircrafts, engines and helicopters, where precision and reliability are crucial. Now at last, what we conclude from this whole PPT, helical gears are efficient for power transmission compared to the spur gear. The ability to handle higher loads and operate between non-parallel and parallel shafts make them vital in industries like automotive, aerospace and industrial machinery and etc. Proper design and material selection and maintenance are essential for maximizing their performance and lifespan. And here are some references, and then thank you.